In this video, we will talk about Sling hygrometer and humidity. There's water vapor in air. Most of the time we don't think about it, but we know it is there, especially when we see fog in the sky or water droplets condensing on the surface of a glass of ice water. We often describe humidity by a term called relative humidity. But what is it relative of? As it turns out, air can hold a certain amount of water vapor in it, called absolute humidity, usually in a unit of gram of water vapor per kilogram of dry air. There is, however, a maximum amount of moisture that air can hold. It is called saturation, and the amount depends on temperature, like this. The higher the temperature, the more moisture air can hold. So, what if we have a moisture content above saturation? Since air cannot hold all of them, the extra amount will condense out as water droplets. But if the amount of moisture in air is less than saturation, we can represent it as relative humidity, which is the percentage of actual amount of moisture with respect to the maximum capacity at that temperature. So by definition, saturation means a relative humidity of 100%. Now let us see what is the relative humidity of a moist air specified by state A here. For example, the actual amount of moisture is 13 gram per kilogram at a temperature of 26 degrees Celsius. Since the maximum amount of moisture that air can hold at 26 degrees Celsius is 21.5 gram per kilogram, the relative humidity is therefore 13 divided by 21.5, which is about 60%. Because the maximum capacity of moisture that air can hold depends on temperature, relative humidity also depends on temperature. Contour lines representing 80%, 60%, 40%, and 20% relative humidities are drawn here with respect to temperature. We can see that if the moisture content is kept the same, decreasing temperature will increase relative humidity, while increasing temperature decreases relative humidity. So how is relative humidity measured? Of course, if you have a digital hygrometer, you can read the number directly from it. But in older times, before electronics, relative humidity can be measured by an ingenious device known as a Sling hygrometer. Today, I will show you how it works. I have a Sling hygrometer here. There is one part that we can pull out, and there is a hinge between them. When we look at one side of it, there are only two thermometers inside, and by just using these two thermometers, relative humidity can be measured. You may ask how. One of the thermometer is open to air, which is called the dry bulb. The other one is wrapped with some cloth, called the wet bulb. The cloth is connected to the bottom of the hygrometer. To use it, we need to first wet the cloth. We can also fill the bottom part of the cloth to make it damp. To measure relative humidity, we just need to sling it around like this. So what happens when we sling it? We are effectively passing air through the thermometers. The dry bulb thermometer will just measure the room temperature, called the dry bulb temperature. On the other hand, the water around the wet bulb thermometer will evaporate. During evaporation, heat is taken away, so the temperature of the thermometer will drop while humidity around it increases until saturation. And the corresponding temperature is called the wet bulb temperature. How much the temperature of the wet bulb will drop depends on the relative humidity of air. The lower the relative humidity, the larger the temperature difference. Therefore, we can measure the relative humidity from the difference in the two thermometer temperatures. We can see it here that after slinging it around for a while, the two temperatures are different. Dry bulb temperature is about 24 degrees Celsius and wet bulb temperature is about 19 degrees Celsius. The hygrometer has a convenient scale to determine the relative humidity. So we set the dry bulb temperature to 24 and the wet bulb temperature to 19 here, like this. We can then read out the relative humidity is 60%. Let us now show you the relative humidity measured by the digital hygrometer, which is 57%, and it is quite close to the measured one by the Sling hygrometer. What if we have another room condition, like the one in a bathroom after taking a shower? Using the Sling hygrometer, we can find out that the dry bulb temperature is 25 degrees Celsius and the wet bulb temperature is 24.5 degrees Celsius. The temperature difference between the two thermometers is much smaller here because relative humidity is higher in this case. From the scale, we found that the relative humidity of the bathroom is about 95%. And we can see that the digital hygrometer also gives a temperature of 25 degrees Celsius and relative humidity of 95. We can also check out the condition of the air coming out from a dehumidifier here. As the dehumidifier already has air blowing from it, there is no need to sling the hygrometer. We can just put the hygrometer at the outlet and wait. We can see the temperature difference gradually increases, and the resulting dry bulb temperature is about 35 degrees Celsius, and the wet bulb temperature is about 22 degrees Celsius. This corresponds to a relative humidity of about 29%. The digital hygrometer gives a relative humidity of 25%, which is quite close to that measured by the Sling hygrometer. After seeing these three cases, I think you understand more about humidity in terms of dry bulb and wet bulb temperatures. Here we will end with a quiz. What do you think is the relative humidity of air coming out from an air conditioner? Is it A 40%, B 60%, C 80%, or D 100%? Comment below if you know the answer and the reason. I will review the answer before posting my next video. Thank you for watching. Bye bye.